Hi students, so today in this video we are going to do some numericals based on mirrors as well as lenses. So first of all, before we start, go through figure 10.9 which is given on your textbook, okay, which talks about the distance towards the left and distance towards the right, okay. So I have drawn a very simple figure here. You can see the distance which is towards the left of the mirror is always negative. Distance towards the right is positive. Now height which is upward above the principal axis is positive, height which is downward is negative, okay. So based on that we will solve question number 1 which you can see on your screen, okay. Question number 1, you are given the height of the object which is 7 centimeter. Object lies above the principal axis, so it is taken positive. The distance of the object from the mirror is denoted by u, which is negative 27 because it is distance towards the left. Then focal length is also a distance towards the left, so it is negative 18. Then you are asked to find the distance of the image, okay, and also the size of the image as well as nature of the image, okay. So let us use the mirror formula. As this is concave mirror, we are going to use mirror formula which is one upon v plus 1 upon u is equal to 1 upon f. Now let's substitute the values. See, this negative will get multiplied here, so this will be 1 upon v minus 1 upon 27 is equal to negative 1 upon 18. Okay, as you shift this sign to the other side, it will be positive. So 1 upon v is equal to, here you are supposed to find the LCM. Okay, so 54 is our LCM. So V, see 1 upon V is equal to negative 1 upon 54. So V will be equal to just negative 54 upon 1, which is negative 54, and the unit is centimeter. So the distance of the image is negative 54 centimeter. Now as you can see, there is a sign negative here. So this distance is towards the left of the mirror, okay. So you can say that it is real and inverted. Okay, now how you come to know whether it is real and inverted or virtual and erect? In case of concave mirror, there are 6 diagrams that we have studied, right? So out of that, only one case is virtual and erect. In that case, the object is formed behind the mirror, which is towards the right. And in that case, object distance will be positive. Only in that case it will be virtual and erect. So here the sign is negative, that's why it is real and inverted. Okay. Now we are supposed to find the size of the image. So for that you need to use magnification formula, which is m is equal to h dash upon h is equal to negative v upon u. Here you are given h dash is not given, upon h is given is equal to negative v, here is negative 54, upon u is negative 27. So if you look at this carefully, these two signs will get cancelled. Now h dash is equal to negative 54 into 7 upon 27. which is equal to negative 14 centimeter. Okay. Now here you can see there is a negative sign here. Okay, so it is negative 14 centimeter. So as the final answer you need to write the image here is real and inverted, and you can see that this is negative 14 centimeter and h is given to as 7 centimeter, which tells you that the image which is formed is enlarged, which is larger than the size of the object. Okay. So this is the second question. Now see, in this second question you are given convex lens. In case of convex lens, if you look at the diagram, the rays come parallel to the principal axis and it will touch the focus on the other side of the mirror. Okay. So as there are two spherical surfaces here, the focus is on the other side. So this distance here is positive. So that's why here focal length is taken as positive. Height of the image, height of the object is 2 centimeter. Focal length is positive 10 centimeter, and object distance is negative 15 because the object lies this side itself. You are asked to find image distance as well as the size of the object. Okay. Now in case of convex lens, you remember that there are 6 cases, just as there are 6 cases in case of concave mirror. Okay. And only the last case is virtual and erect in case of convex lens. Okay. Now in case of convex lens, the last case is when the image is formed on the same side of the lens. Okay. In the rest of the cases, the image is formed on the other side. So you have to see now whether the answer that you get is positive or negative. Okay, so let's begin solving. You are asked to find object distance, image distance as well as size of the image. Okay, so let's use lens formula. Now see, this negative will get multiplied here, so it will be positive this side. So when you take it to the other side, it will be negative. Now taking LCM of these two, just the same way as we had done in the first case, you will get LCM as 30. You can try it yourself. So in this case, 1 upon V will be 1 upon 30. So V will be positive 30. So this is not the last case, okay? Because in the last case it will be negative, okay? Because it is lying on the same side. This is the case when the image is formed on the other side of the lens, okay? So which will be formed somewhere here on the right side, okay? So we have calculated this now using the magnification. Let us calculate the size of the image. So let's substitute. So h dash is equal to negative 4 centimeter here. Now as you see, this is positive, so you can say that the image which is formed here is real and inverted. Okay, so that's your answer. Okay, let us solve question number 3 now. In this, you are given concave mirror and you are given magnification is negative 1. Also, you are given that the image is located at 30 centimeter and it is real image. Okay, so that's why the real image is always formed on the left side. That's why it is negative 30 centimeter. Now you are asked where is the object placed to get this image. Okay, so let us calculate it. As the magnification is given, you can directly use magnification formula here. So m is -1. So or u will be equal to -30. Okay. So u, which is object distance, is -30 centimeter. Okay. Now see, next you are given that the object is moved 20 centimeter towards the mirror, right? So you are not given the object distance in the next case. So to find that, what you can do is first find the focal length, okay, using the mirror formula. Okay, now next you are given that the object is moved 20 centimeter towards the mirror. You are not given the object distance in the next case. Okay, so you can find it. That is, see, if suppose this is the mirror, the first distance was -30 centimeter. Now it is moved from here to this place, which is 20 centimeter away from it. Okay, so you can find it by subtracting this distance. See, this will also be -20 because it is located towards the left side. Okay, so your answer will be -10 centimeter. So next distance, object distance is -10 centimeter, and you are supposed to find where the image is formed in this case. Okay, so to find that you need focal length. Okay. So let's use this formula. So f will be equal to -15 centimeter. Okay. Now the question is not over here. You are supposed to find when the object is moved towards the mirror, 20 centimeter towards the mirror, where the image will be formed. Okay. So now next case, you need to first show this calculation, and after that you can calculate the image distance. See, this will get multiplied here, so it will be -1/10, which if you take the other side, it will be positive. So again here you need to find the LCM. Okay, so as the image is 30 centimeter, which is positive, you can say that the image is virtual and erect. Okay, so that's your answer. Okay, so in question 4, we are given concave mirror. Okay, and in case of concave mirror, it is told 3 times bigger image is formed. Real image is formed. When the real image is formed, the sign of magnification is negative. Then it is told image is at the distance of 60 centimeter. Image which lies on the same side of the mirror, meaning -60 centimeter. And you are asked to find object distance as well as focal length. Okay. So let's use the formula of magnification for the mirror, which is -v/u. So let's substitute the values. So magnification is given calculated the object distance, which is negative 20 centimeter. Okay. Now we are asked to calculate the focal length. So let's use mirror formula. Now here you are supposed to find the LCM without taking the signs. Okay. Why you are not taking the signs? Because signs lie here. Okay, this plus into minus will be minus. Here it is minus. Okay. So in the numerator you have negative 1, negative 3 upon 60. So now f will be equal to 60, negative 60 upon 4, which is equal to negative 15 centimeter. So this is your answer. You are asked to calculate object distance and the focal length. So here is the answer. So this is question number 5. Let's see how to solve this. You are given object size, you are given object distance, focal length, and you are asked to calculate image distance as well as image height. Okay. So let's use the formula to find this. So this is concave mirror. Let's use concave mirror formula. So here again it will be negative 1 upon 15. So when you take it to the other side, it will be positive 1 upon 50. Again take LCM here. So V will be negative 30 centimeter. Now see, when the image formed is negative 30 centimeter, it means that it is formed on the same side where the object was kept, because this is the concave mirror, right? So if it was virtual, then it will form on the right side of the mirror. Okay. So here you have to say the screen should be placed on the same side 30 centimeter. It should be placed 30 centimeter on the same side of the mirror. Okay. So the screen should be placed 30 centimeter on the same side of the mirror. Now next you are asked to calculate size of the image. So let's use magnification formula. So h dash, we are asked to calculate. H is given 4. So the signs will get cancelled. So h dash is equal to negative 8 centimeter, meaning the height of the image is negative 8 centimeter. So that's your answer. Okay. So we were asked to calculate V as well as h dash. So this is how to calculate it. Okay. So this is 6th question. And here you are given concave lens. Okay. So this is the image, how it looks of concave lens. Now by looking at this, we are marking U, which is object distance is negative 14 centimeter. U is always negative whether it is for mirror or lens, because object is always placed on the left side. Now focal length is negative 21 because focal it gets diverged to this place, towards left side. When the ray comes parallel, it gets diverged here. So it is negative 21. You are asked to calculate you are basically asked to describe the type of image form. So for that matter, we need to calculate V as well as H dash. Okay. So let's use lens formula. Now here this will get multiplied. It will be plus 1 upon 14. So when you take it to the other side, it will be negative 1 upon 14. Okay. So you need to find LCM. Let us find it here. Okay, so you have to multiply all these. So all these terms you have to multiply. You will get your LCM here. Okay, so you can see that we have written the LCM part. Now 1 upon V is equal to, so V will be equal to we will be equal to negative 8.4 centimeter. Okay. So now see, as you can see that it is negative 8.4 centimeter. So it is formed on the same side. That means it is virtual and erect. Okay. The image which is formed is virtual and erect. You have to write. Otherwise also for concave lens, you know that the image which is formed is always virtual and erect. Okay. So you first write the description here, and after that we are calculating height of the image. So this is the magnification formula for the lens. H dash, we are calculating H is 3, V is negative 8.4 upon U is negative 14. Okay. Okay, so negative sign will get cancelled. So simplify these and you will get the answer as 1.8 centimeter. Okay. Now if you look, the size of the object was 3 centimeter, whereas the size of the image is 1.8 centimeter. So you can say that the image which is formed is smaller than that of the object. Okay. So first you are writing that the image which is formed is virtual and erect, and the image which is formed is smaller than that of the object. So that's your answer for question number 6.